Okay, I want to talk about the regulatory regime applicable to the White Mesa Mill and all the environmental protections that are in place. I want to also focus a little bit on all of our recycling programs. And then I'll talk about sustainability. Uh, the White Mesa Mill is regulated under the Atomic Energy Act as amended by the Uranium Mill Tailings Radiation Control Act called UMTRCA. Our primary regulator is the state of Utah Department of Waste Management and Radiation Control. UMTRCA was enacted in 1978 in response to some poor performance by the United States in the Cold War legacy. During the Cold War years, the 50s, 60s, early 70s, the United States government sponsored the production of uranium for defense purposes. It wasn't very well regulated, left a lot of abandoned uranium mines, abandoned uranium mills in the West, a lot of them on the Navajo Reservation. 1970, and in fact, one of the biggest stories for that was the abandoned uranium mill tailings near Grand Junction, where builders and homeowners were taking the sands, which were abandoned, using those for construction purposes, which was radioactive, and there was radioactivity in basements and things like that. So it was a major cleanup effort. In 1978, Congress said, never again are we ever going to have an abandoned or orphaned uranium mill tailings site. So they enacted UMTRCA to put in standards to clean up the existing abandoned uranium mill sites, to put in standards for the construction of new uranium mill sites, to make them protective so that there would never be a repeat of those problems. So so kind of in short, and I'll go into more detail on some of these things, but what UMTRCA did was, and it was surprising to me that by 1978, uranium mill tailings weren't that well regulated. 1978 wasn't too long ago, and I was surprised at that, but they certainly are regulated now. So what UMTRCA did was it basically put in siting criteria, saying, you have to site a mill in a certain place. I'll talk about that. There are strict design standards on tailings impoundments, 1,000-year criteria. Strict operating standards were put in place. Strict monitoring and reporting requirements. The requirement for an approved reclamation plan was a surety bond. That was something new at the time. And probably most importantly, or most interestingly, the transfer of reclaimed tailings cells to the U.S. government for long-term ownership and care. So siting, prior to UMTRCA, mills were often placed in the most convenient location for mining. They were usually placed right next to a mine, whether that was a good place or not, often in a drainage, could cause a lot of problems. What UMTRCA did was it put in criteria, and the White Mesa Mill was sited in response to those criteria. The first is it has to be remote from population, and that was the case at the time. It has to be in a good hydrological natural setting, because there's a 1,000-year design standard, and there has to be natural protections in the event man-made protections fail over that time period. They must be in situations where seismic and climate criteria are not a factor, and the primary emphasis on isolation of the tailings. So this site was chosen with all those features in mind, which provides a lot of natural protections over that 1,000-year design criteria. I talked about the tailing cells. One of the key design features is that tailing cells for uranium mills have to be designed to a 1,000-year standard. That's a higher standard than any other facility in the United States. Low-level radioactive waste facilities have a 100-year design standard. Class C facilities, which are the hottest low-level waste facilities, are 500 years. A typical RCRA hazardous waste facility is about a 30-year design standard. So 1,000 years is a long time. Originally, tailing cells had one synthetic liner. Our older cells are like that. Modern cells that on our currently active cells and our future cells have triple liner system. I'll get into a bit of detail of that in a minute. We have leak detection systems, very very well engineered leak detection systems and dewatering systems in our tailing cells, and a cover design that is engineered to make sure there's no infiltration after closure. This is a little schematic. What our Our tailing cells 4A and 4B right now have a triple liner system. There's a 60 millimeter HDPE liner. That's the initial liner. There's a porous layer under that, and then there's a second 60 mil HDPE liner. Underneath that's a clay liner. So the theory is that if there was ever a leak in the top liner, you detect it in the leak detection system, which is between the two liners. And if there was a leak, you could pump any leakage out through there, taking the head off of the second liner, so you wouldn't get anything through the second liner. The third liner is for extra protection. So the chances of anything getting through that triple liner system is virtually zero. The way the system is designed is that when a mill is actively operating, we monitor in that leak detection system because the tailings are wet. Once cell is filled up, we use a dewatering system to dewater the cells so that most of the moisture is taken out. So that over that 1,000-year design period, should the synthetic liners fail in year 800, there won't be any force for any liquids to go down because there'll be a static equilibrium. So very, very well engineered and very protective. Operating standards, we have to manage our doses to members of the public and workers. Doses are from, air particulate, which is dust, radon, which comes from radium on site, which is a natural byproduct of our ores, or a daughter product of our ores, and gamma radiation. The occupational standard is 5,000 milligrams per year. That's for each worker. For members of the public, it's 100. We also have an as low as reasonably achievable standard, ALARA, which means that we always try to beat the standards as much as possible. And we set a goal to never exceed 25% of the standard. So that would be, in the case of our workers, 1,250 milligram per year. Well, our typical doses for workers are around 200, so that's about 4% of the standard. So we have a very protective site in that respect. Our modeling for our public shows that we're well within the 100 milligram per year standard for the public. We also have standards on radon emanation from our tailings, which we have to monitor all the time to make sure that radon levels from the site are within regulatory standards. Our occupational safety, by the way, is regulated by the Mine Safety and Health Administration, MSHA. We've got a lot of monitoring programs, air particulate. We've got 33 locations around the mill site for worker protection. We've got 7 environmental stations on the perimeter of our site and around. We monitor for air particulate quarterly. We have radon monitoring at basically those same stations, one additional environmental station. Same for gamma radiation. So we make sure that we don't exceed our standards. And in fact, we're within our ALARA goal, which is 25% of those standards at all times. We have soil monitoring at 52 locations, vegetation at 3 locations, surface water 6 locations. Groundwater is very important at the site. It's 47 constituents we monitor and 29 wells around the site. The groundwater of the mill is interesting because one of the features of our siting criteria is that our hydrological siting is actually pretty ideal because we've got a perched aquifer which is very discontinuous and low flowing, about 150 feet below the tailings. We then have a regional aquifer about 1,000 feet below that, separated by impermeable rock. So the chance of anything getting to the regional aquifer is virtually zero at this site. Yet the perched aquifer provides an early warning system. So if there ever was to be a leak from our tailing cells, which is extremely unlikely given the triple liner system, if there ever was a leak, we would pick that up in the perch zone, and we could remediate it while it's in the perch zone. The water flows very slowly at the site. It takes about 1,500 years to get from one end of the tailings cell to the other, about 2.74 feet per year. So the amount of time it would take to get to the nearest spring off-site would be about over 10,000 years. So we have plenty of time to remediate any potential leakage that could come from our tailing cells, which is extremely unlikely. So that just goes to show you how the UMTRCA siting requirements, along with the design standards, work to combine natural protections along with man-made protections. We've got we file about 50 reports annually. A lot of them are 1.5 inches thick, most of them probably. We have typically about 20 inspections from the Division of Waste Management and Radiation Control each year at the site. We have 2 or more MSHA inspections of the site, and all of those 50 reports we submit annually are also inspected by the regulator. So we're monitored. For reclamation, that's another cornerstone for Umpqua. You need a reclamation plan, and the reclamation plan has to basically, we have to allow room in our tailing cells to take all of our buildings, tear them down, put them in the tailing cells, all of our liners or VAP ponds, put them in the tailing cells. Any wind blowing around the site, we clean up, we put that in the tailing cells. Then we put that engineering cover on the tailing cells to put a fence around it. Everything that's not fenced is ready for free release. So we clean it up so it can be used for free release, residential, any other use. We have to put a surety bond in place for that, and we currently have a surety of about $24 million to make sure that happens. Again, that's a key feature of Umpqua. And I mentioned earlier the transfer to DOE. Once those tailing cells are reclaimed and fenced, we then transfer that land to the U.S. Department of Energy. Title goes to the Department of Energy, and they take care of it in perpetuity. There's no other facility in the United States that has that protection. And in fact, there's no other facility in the world that's private that has the government step in and take it over for perpetual care. That's an amazing feature of this. And again, that's the Congress in 1978 saying we will never have an orphan uranium mill site ever again. What that means is that the chances of there ever being a Superfund action for mill tailings are virtually zero, and it provides protections for people who send us ores and materials for processing, that they know it's going to be finally disposed of without worrying about future liabilities. So let me talk a bit about our recycling. We're proud of that. You're very, very, very proud of that. The first thing I'll talk about is alternate feed materials, which are uranium-bearing, basically waste products from other facilities. Sometimes you've got other ores that are mined for titanium. They've got uranium associated with it. The tailings of those facilities have uranium in them. That becomes a regulated problem for those facilities. They can ship it to us. We then run it through our mill and recover the uranium, which would otherwise have been lost to disposal, and then dispose of the tailings in our tailings facilities. So far, we've recovered over 5.3 million pounds of uranium from alternate feed materials that otherwise would have been lost to direct disposal had the White Mesa Mill not recycled that uranium. Each alternate feed material requires a license amendment, so the regulator has to be satisfied that any new materials have been analyzed and that can be processed safely within the environmental assumptions and license conditions of the mill. Pond returns. This is something we're also very proud of. Our mill guys are very ingenious when it comes to utilizing this mill and processing it. We developed methods to recycle our tailing solutions, which had been wastes from our previous process, to recover about 670,000 pounds of uranium from pond returns. And that's about half of what our Arizona 1 mine has from a primary mine. All of that uranium was basically written off as waste, which we recycled to recover the uranium. And the uranium was then put into the nuclear fuel cycle to create electricity for Americans. AUM materials, that's abandoned uranium mines. I mentioned the Cold War legacy. There are a lot of abandoned uranium mines, a lot of them on the Navajo Reservation. We can take those contaminated materials, which are basically uranium ores, and we can run them through our mill as ores and recover the uranium from that. Vanadium, we're also proud of this. I think you've heard earlier, we produce vanadium in some of our uranium ores. Well, our mill guys also figured out a way to recover vanadium from tailing solutions, and we recovered 1.8 million pounds of vanadium from our solutions, which was written off as being waste. We recycled that amount of vanadium. Rare earth elements, we take those as uranium ores because they have about as much uranium as a typical Colorado Plateau ore has. So they're uranium ore. They're also rich in rare earths. Not unlike our uranium ores that have vanadium and uranium, these ores have rare earths and uranium. They're natural, so we take them as natural ores. We can recover the uranium as well as a rare earth element. It's small throughput. Our mill is designed and licensed to handle about 730,000 tons of uranium ores per year. we're ramping up to about 40,000 tons of monazite per year, which is a very small percentage of our total capacity. It would be about 20 days of a full mill run. Now, monazite has been, if you've listened to Jack Lifton's talk, monazite has been considered to be a waste because it was radioactive and was a problem for heavy mineral sand operators. Well, we're taking that monazite, we're recovering the uranium and maybe even the thorium in future years. So it's a form of recycling as well. We talked a bit about the target alpha therapy. Again, our ores contain radium. So we have radium at this site. It's all over the place. And that's what generates the radon. We have to control it. We're licensed to deal with radium and radon. What we're able to do here, though, is we're able to, working with RATTN, we're able to recycle that radium, which would otherwise be a waste, sitting in our tailing cells, generating radon. We can take that, recover it, reduce the amount of radon coming from the site, and use it to for pharmaceutical companies to do cancer treatments. What I have underlined there was one of my favorite things, and our Pinyon Plain mine has got about enough radium-226 in it to provide hundreds of thousands of treatments per year, possibly cures. You saw the one German fellow here was cured. Hundreds of thousands of people like that can be cured annually for many years, up to 25 or 30 years from that one mine. All of that would have been, in past years, would have been disposed of in our tailing cells as radium. We're now taking that, our plans to take that out, recover the radium, get it off site, save lives, reduce the radiation on the site. Another form of our recycling. So, sustainability. What does all this mean? Well, as a uranium company, we produce nuclear energy, which is the largest carbon-free source of energy. The U.S. gets 20% of its electricity from nuclear, about 55% of its carbon-free electricity. So that's our starting point. What we produce is good for combating climate change. But we also do our recycling programs. I talked about the uranium from altered feed materials, pond materials, from monazite. We get uranium from that. Talked about vanadium from pond returns. Uranium, rare earth elements, and radium, etc., from uranium ores. To date, from these recycling programs, the mill has recovered over 6 million pounds of uranium and 1.8 million pounds of vanadium. Again, these would have been disposed of permanently at other facilities. We recycle them to recover that. Well, what does all that mean? Well, that amount of uranium would produce about the same amount of electricity as 50 million tons of coal. That amount of coal, just so you can picture it, and Curtis or someone gave an example of this earlier, but it was a shorter train. If you put it all in one train of coal cars, it would stretch from Los Angeles to New York, and as of 2021 till about Las Vegas. We've been recovering it now. We've probably made it back to LA at this time. So that's a continuous train of coal cars across the country and back again. That's the amount of coal equivalent we've recycled, which is carbon-free energy production. That amount of electricity would be provides much electricity is about 24,500 wind turbines, which is half of the U.S.'s wind turbines as of 2019. This recycled uranium would eliminate over 85 million tons of CO2 emissions, the same amount of annual emissions as 18 million passenger vehicles annually a year, or 1.5 times the total CO2 emissions of the country of Sweden for a year. All from stuff that we pulled out of wastes that would otherwise been lost, all the way Mesa Mill. Over 110 millions of forest, which is larger than the state of California, would be, or 1.4 billion seedlings, which need to grow for 10 years to sequester that amount of CO2 emissions. So we're very proud of our programs. No one else can make those claims. No other uranium mill can make those claims. The 1.8 million pounds of vanadium that we recovered that has been written off as a waste, when converted into steel girders, would make 4.5 Golden Gate bridges. All of that was lost until our guys figured out how to recover. The rare earth elements we are recovering from monazite will help produce electric vehicles, wind generators, and will also help reduce the world's carbon footprint. Again, no other facility in the world can claim these types of sustainability features. You heard about the Clean Energy Foundation. I won't say much more about that. That was a good discussion. I'll say this, that the total amount granted today to spend around $400,000 all to, we're extremely proud of that program. I think it's a great program, and we're really complimentary of our advisory board and the ability to identify and just distribute those funds to worthwhile causes in the county. So, some concluding remarks. Uranium, it's a fuel for carbon-free emission-based nuclear power. It's one of the cleanest forms of energy in the world. That's what we produce here as our primary product. The rare earths we are now producing are used for the manufacture of permanent magnets, for electric vehicles, wind turbines, and other clean energy and modern technology. And the radium and other radioisotopes we are evaluating for recovery from our rare earths and uranium processing streams have the potential to provide isotopes needed for emerging targeted alpha therapy, cancer-fighting therapeutics. The very heart of our business, uranium and rare earth production and recycling, helps us play a big part in addressing global climate change, reducing air pollution, and making the world a cleaner and healthier place. This is truly a generational opportunity to restore critical mineral processing in the United States, and Utah and San Juan County are in the box seat to lead this charge. So that's all I really got to say. Anyone have any questions? I know I've covered a lot of ground here pretty fast. I think I talked pretty fast. I apologize for that, but okay, thank you.